Hey everybody, hope you guys are doing well. In this video, we're going to set up a self-hosted cluster on EC2 instances. We're also going to set up a load balancer, which will expose our application that we're going to deploy in this demo to internet, and then you could essentially kind of access your application accessing a particular URL link. In this demo, I do have a domain. I'm going to set up a subdomain and have it translated to my load balancer so that I could access my web application over the internet. I will also set up the SSL certificate. We'll cover everything as we progress. So this is the diagram. So for this demo, so we're gonna have two private and two public subnets. In private subnets, we're gonna have our Kubernetes self-hosted cluster. There's gonna be one control plane and two worker nodes. Control plane won't be accessible from internet. We're going to use Bastion host, which will be sitting in public subnet with the public IP address. If Kubernetes clusters or apps need to access any sort of application from internet, they can do so just using the NAT gateway, going to internet gateway, and then eventually pulling the images from Docker Hub or any sort of public repository where you may have your images. Everything that we're going to cover is documented on a GitHub repository. I've prepared a relatively comprehensive guide. That's what I'm going to follow. In this video, I'm not going to go over the little details on how you set up a cluster. I do have a video available on that, how you set up self-hosted cluster. Please do check it out. In this video, I'm going to use a script instead that will configure my cluster, install CNI plugins, disable the settings that's the node's supposed to have it disabled, and then eventually initialize our cluster. So we'll go over that script. And when it comes to provisioning the infrastructure, I'm going to use the Terraform. Again, I've covered that in another video. Please do check it out on how you can use Terraform to provision infrastructure for your Kubernetes cluster. So I'm going to use that, and I do have the script and the Terraform code prepared. We'll just go over it just to see what's happening and what that code is doing. So let's quickly review the bash script first. So the what bash script does here that the first it will set up the host name, and then I will check if the memory and CPU is sufficient wherever we're gonna configure or initialize the Kubernetes cluster, and then it's gonna disable the swap and then enable the port forwarding, and then it will just kind of make sure that it's enabled. If it didn't get enabled, it'll quit the script. So it's kind of like the logic. You're gonna see that and throughout the script, where if certain things don't get enabled or installed as you expect to, the script will exit. And then what it does that there is a function to install any sort of a package that we would need to anywhere in the script. And then what it does, it grabs the latest containerd version, stores it in a variable, does the same for runc and CNI version. And then based on the architecture for your node, if it's AMD or ARM, it will install containerd, download the directories that it needs to create all the directories, and then after that it will also configure containerd for you. Some of the settings need to be changed in config.toml file, so it'll do that for you. After that, it will add Kubernetes repositories to your node and install Kubectl, Kubeadm and Kubeadm tools on all nodes. And at the end, it'll have a logic ask you that if your node where you're running the script, this is a control plane, and if it is a control plane, it will initialize your cluster using this CIDR. 192.1.68.00/16, and it will also configure Kubectl for you on that machine. And if it's a worker node, it'll exit the script once the kubelet and Kubeadm is installed. So if you want to just use the script in your environment to set up a cluster, you can do that, and all you have to do is just kind of modify the pod CIDR based on what you wanted to use. And that's with the script to set up a cluster. And let's go over the Terraform code. So here, let me just quickly open it on VS Code. It'll be we can go over it relatively easier. So here we have a provider file, which is going to initialize my AWS provider, and there is the variables. There are a whole bunch of variables available. They are descriptive enough. You can go over it. We are defining the region, then the CIDR block, VPC name, the tags that we want to have it applied to all of our resources, and the master node and names for the worker node and for the Bastion host. And one thing I want to point out that you just got to have a key pair available for this demo. If you do not have a key pair available, I would strongly suggest you to kind of create one and then kind of add that value here, so that this value won't work in the environment. So you have to have a key pair created and available. And then I'm defining the clustered type, the node type I want to use for my cluster nodes. It's T2 medium and T2 micro for my Bastion host, and the volume size, I'm keeping it limited here. And then there are some sort of a load balancer related variables. So load balancers, where we're going to create the load balancers, those subnets gotta have the ELB tag available. If we're creating a internet facing load balancer, the tag name would vary if we're going to set up a internal load balancer. This one, I didn't end up using it, but we actually using the variable, but the future I have it in EC2 instances that we're gonna disable the source destination check on EC2 nodes. If we want to have our pods communicate with sitting in a different nodes, we gotta have that feature turned off. It is turned on by default on all EC2 nodes, so you just gotta have that disabled. And this is the variable file. Next we have VPC. I'm using VPC module. I'm also using dot as a resource to get the availability zones, and I'm going to use them to describe what sort of availability zones I want to use. Then I'm defining the CIDR for both subnets, telling if I want to create the internet gateway, and then defining the configuration for NAT gateway. After that, I'm providing the tag values for the VPC, and I'm also explicitly defining the tags my public subnet is supposed to have. Again, the tags are expected by load balancers to have it on our public subnets. And then I'm creating two security groups. So the first one which will attach to Bastion host, it has SSH inbound allowed from anywhere, and another rule that has that any internal traffic within the security group is allowed and all outbound is allowed. The security group that we're going to attach to worker nodes would have outbound allowed, everything internal allowed as well within the security group. And then we also allowing all the traffic coming from Bastion host, that's the security group where the Bastion host is sitting. I could explicitly define only port 2022 or something like that, but Kubectl may need to communicate with our API server for the port 6643 and other different ports. I could define those roles since the traffic is coming from the security group, not from some sort of external source. I'm not too much concerned about that. So I'm just going to leave it as it is, that allow all the traffic from the resources that are sitting in another security group. After that, I'm creating IAM role. First, we have providing the IAM instance profile that will attach to our EC2 instance, the IAM role, and then there's another resource which will attach the policy below with our role. So when it comes to the policy that I'm using, it's available in the documentation. I'll leave the link below for you guys. it tells you what policies should be attached to our EC2 nodes so that they could create load balancer on our behalf whenever we create ingress rule. So yeah, so we just gotta have that policy. Of what I've done, that I've downloaded this policy based on this documentation, and just kind of essentially paste it here. Then we have another file which is creating our EC2 instances. At the top I have AMI data, data resource, which will pulling in the latest AMI ID for me for Amazon Linux distro, and then I'm using it for my EC2 nodes. And then I have defined other things that I want to define for my EC2 nodes, like instance profile that I'm using, instance type, I'm using the variable, and I'm using the variable for IAM profile as well. It's referencing from the IAM file what the profile name should be. And then I'm disabling the source destination check, as I mentioned why we need to have it. And then I'm using the variable to provide the key pair name, and similarly then I'm referring security group from the VPC file, the security group that I want to use, and the subnet ID is getting reference from the VPC resource that we're creating here using the module. And then at last I'm using the volume size, and then I'm using the tags that we defined in our variable file. I want to have it applied, and I'm merging another tag which would be it's kind of essentially providing the name for this node that we're going to create, so that it's easy to distinguish on our portal. I'm doing the same for our worker nodes and the Bastion host. And the last file we have the output. So output is basically outputting IDs of the nodes that we're creating and their IPs. Only Bastion host is going to have public IP, other nodes going to have private IP. So we're going to connect to the Bastion host and then connect to our nodes that are sitting in private subnet. So let's create the infrastructure first. So I'll go to my items. So this is, I'm in the directory where my files are sitting. So I'm just going to confirm that again. Everything is available in the GitHub repository, and you could definitely just essentially clone this folder or the repo and just do the same thing I'm doing. The things that you probably would need to modify, things are like the part cider. That's pretty much it. But other than that, everything should just kind of work just fine. Let's initialize our Terraform code. So I'll run Terraform init. So what Terraform init is going to do, download the plugins and the module. Then I'll run Terraform plan just to see if there are any errors. I shouldn't expecting that. I just checked the code before I started the video. So everything is looking good. The values are not known yet. We'll know them once for the outputs once the resources are created. Let's just quickly clear this and then run Terraform apply. So most of the resources will get created relatively quick. Some of the resources do take a little longer, resources like NAT gateway, but other resources will get created relatively quick. But for the NAT gateway, like I said, it'll take a minute or so. We'll wait for that. So our resources have been created. It has outputted the IPs and instant IDs. What I'm going to do, I'm just going to copy this one and put it in some sort of a OneNote, on my notes, so that I can reference them later on whenever we need to connect to those instances. So now if I just I'm following this README too. It's the same, and the steps are written the same order that I'm performing in this video. So the next thing we gotta do once our infrastructure is provisioned, first thing I'm going to do, I'm going to copy the PEM key to the Bastion host so that I can connect to my nodes that have that PEM key associated. So this is the command that will just copy this one real quick. I could, let me just move to the different tab here, first thing first. So I'm using SCP to transfer the files. First thing I do, I'll copy this one. Oh, it's expecting variable Bastion IP. So let me quickly define that one. The Bastion IP, the address should be, okay, let's provide this one. enter it. If I run that command again, it will copy the DevOps keys to my Bastion host's home directory for EC2 user. So I'll do that, and it's going to confirm that for the fingerprints, and it's just moved my DevOps PEM key to my Bastion host. The other thing I wanted to do, I'm gonna use the tmux. So once we're on the Bastion host, I wanna able to connect to all of my nodes at once. Tmux is pretty neat tool. I've been using it for a while. I'm gonna use that to connect to all of my nodes at once. So I do have custom settings for tmux. So configuration, I'm gonna copy that to Bastion host as well, so that I'm not surprised with the new key bindings and everything like that. So we'll quickly move this. After doing that, I'm gonna connect to the Bastion host. Okay, so now I'm on my Bastion host, and the next thing I'm gonna do, I'm gonna install the tmux, do a quick update, and also gonna change the host name to Bastion node. So the commands are listed here. I'm gonna copy it, run it here real quick. Oh, let's just switch the tab, go back to where I was, and install tmux and git. Tmux is, again, I said that why I need it. Git is something that, you know, it's nice to have it. I may end up using it here. Actually, I may not, but Git is kind of like a standard tool. If you have it on a Bastion host, it's not gonna harm you. So now what we're gonna do, now we're gonna connect to each host from the Bastion. So let me just quickly exit out of here and reconnect so that my node name or it reflects. So now it's saying Bastion node. Cool. So now I'm gonna run tmux, and the configuration should have been copied, or looks like it has. So I created 3 pans, and we're gonna connect to our 3 different nodes at once. So I'll copy this one, specifying the key we want to use for SSH, and then we're gonna provide the IPs for each node. Do the same for this one. We're gonna get the IPs for our worker nodes and the control plane. I'll copy this one real quick and do the same for worker nodes. Now we're gonna connect to each node. Okay, so now I'm connected to all of my nodes. I'm gonna enable the synchronize mode so that whatever the command I type in one pane gets synchronized or get typed on other panes as well. What's going on here? Okay, now it's synchronized, turned on. So let's clear the window for all of our panes. So if I go to my README, it tells you how I can download the script from this directory or this repo. So I'll do that using wget. So we'll download the script on each node. It shouldn't take long. It's a relatively small file. And the next thing we're gonna do, we could change the permissions for it and then run the script. So let's change that. Now run the script. Change the host name. I'm gonna turn off the synchronize mode, so the node name can be the same for all nodes. So this one is gonna be worker 1. This will be worker 2. Enter on this one too. This one here too. As we gone over the script, is gonna check the things that we needed to have it before we could set up a node for our cluster, and will be prompted for if the script is running on control plane or worker node, and then we'll configure kubectl or on the node or not. So here we prompted. So for worker nodes, I'm just gonna type in no, that I don't need to have a kubectl installed on worker nodes, but for the control plane, of course, and it will also initialize the node for us. This will take about a minute or so. If you're seeing this message, just ignore it, since we changed the host name and we haven't restarted the node, so the DNS doesn't know what the host names are yet. So if you're seeing that warning, don't be warned. So okay, so now it had at the end generated the command that we can use to run it on our worker nodes. I'm not gonna do that yet, but what I will do, I'll have it copied sitting somewhere on my nodes, and then I can use it later. So first I want to set up my CNI plugin on the control plane. So there are commands available. I'm going with Calico network plugin. This commands will install the latest version. And what's going on here? Oh, I was running the Kubeadm command. It didn't get copied correctly. Let's just copy this one more time and run those commands here. So we're gonna install the CNI plugin using Kubectl, and at the last it's gonna run the watch command, which will get refreshed every 2 seconds and kind of display the status of our Calico pods that are being created. You may see certain errors. Don't get scared about that. Some of the pods rely on other pods to be created. So if you're seeing errors, just wait for a minute or so. And wait for all the parts to be created. You'll see that their status changed to running, and all of them would be in the ready state. So I'm just gonna wait for 30 seconds here. Okay, so all of our Calico parts are in running state, and all of their initial the containers within the pods are ready too. So I'm just gonna exit out of that and clear my window, and now we're gonna join our worker nodes to the cluster. So as I had copied my command, so I'll copy this one and run it on my worker nodes. So it expects to be run as sudo, so just make sure that you type in sudo in front of the command that you were provided, and once they've joined the cluster, you'll get a message that the node has joined successfully. If you want to list them on our control plane, we could just run kubectl get nodes, and there they are. So all of them in the ready state. They wouldn't be in the ready state if the network plugin hadn't been installed. So network plugin is enabling the communication between the different nodes and the pods. Please keep in mind that at this point, some of the Calico nodes, the pods might be getting created for different worker nodes. So we probably want to wait for them to be created. So if I just run kubectl pods in Calico namespace, you'll notice that some of them are still being created. Actually, it's been almost a minute or so. So there's only one pod that is pending, which is it's ready now too. So everything is good, but in case before you go to the next steps, just make sure that all the Calico pods are running in ready state. So after we have configured our pods, the nodes as we wanted to, the cluster is set up, they have names been given and everything like that. So what we're going to do, we're going to disconnect from our nodes and manage our cluster from the Bastion host. We no longer need to stay connected to our control plane. So we'll do everything from the Bastion host from now on. So let's just detach the tmux session. I'm just going to keep the session running just in case if I need to connect to them. So we're going to configure our Bastion host and install the kubectl on it. So there are commands available similarly how we ran it on our master nodes. We're gonna add the repo and then install the kubectl. Clear this command. Now we're gonna copy the configuration from our control plane. So it's gonna use the the master IP as a variable. So what I will do, I'll define that environment variable, and we gotta provide the IP for our control plane node. So this is the one, so that it could copy the Kubectl configuration from our control plane node. Now we're gonna copy these commands and run it. So first it's creating the kube directory, and the second command, similarly we did it early on, is using the SCP to copy the kubeconfig file to our the Bastion host kubeconfig directory and the file. So and then we're changing the ownership so that the user that's running on the machine now could access that config file. So after doing all this, if I run kubectl get nodes, I should be able to connect to the Kubernetes API server and get the information about the resources that are running on it. If I just do kubectl get parts, all namespaces, I should be able to get the list of the parts. Everything is looking neat, all of them in a running state and ready. So perfect. So the next thing we're gonna do, we're gonna install the load balancer controller. So I'm using Helm here. So what we will do, we'll install the Helm first, and then we'll add the EKS repo to, and then using Helm, we're gonna install the cluster. So the only variable here is that the providing the cluster name. We didn't specify any different name when we initialize our cluster. So by default, it's gonna be Kubernetes. But if you have provided a different Kubernetes clusters name during Kubeadm initialization, you done it your way, you probably would have to provide the name accordingly. So yeah, let's quickly do that. Install the Helm on our Bastion machine, and then using Helm install the load balancer controller. So load balancer controller is required for us to create load balancer on AWS account. So once the load balancer is created, now we're gonna deploy our app. So I'm using, there's a web app that I've developed. So basically, we will see that shortly once we access it on the client on the browser. But it's just a lightweight Flask application. And we have a multiple applications. So there's one application to access the blog homepage, another application for login or login and log out. So if I view the manifest here in our in the repository, first we're creating deployment. In the deployment, we have making sure we have 2 replicas and defining the selectors. We define the metadata here, and then the template, we telling what sort of container we're gonna have and what port it is being exposed. Image pull policy, you could change it or maybe remove this part. One point in time I had to set this one to always pull it whenever the deployment or the parts being created. And then I'm passing some of the variable that the app expects. So it is expecting login URL and logout URL, which will be passing it using config map, which is declared below in this file. And then I'm creating the service. So I'm going to use the service to expose my blog app, and it's going to use the node port 311, and the target port is what the pod is exposed at, and this is the service port. And then I'm creating another deployment, which will be for the login app, and it's using the image, again pulling it from my Docker public repository. That the port that the Docker is exposed, or the container is exposed on, is 5002. So I'm specifying that. And this app also expects you to pass a variable base URL. The only reason we have this variable so that the 2 apps can communicate with each other, or there's some sort of a redirect link available. And then we're creating the service to expose the login app. And at the bottom, I'm creating config map and passing in all the URL that the app is supposed to have. I have the domain names available. You could, if you have your own domain and you're gonna use whatever domain you have it available, you can pass that here. So I don't know, you have another name, domain name or something like that. You can just pass the value here accordingly. If you just leave it the way it is, the apps will still get created. They'll still be in working state. Just the redirect between the apps won't happen. So that's our manifest. So if I go to the my README, it tells me to download this from this repository and then install it. So let's quickly download this manifest on the Bastion host, and using Kubectl we will create the resources that we have defined in our this manifest file. So if I do this one, it should have created 4 pods. They are being created in default namespace, and so you should be able to just do kubectl get pods, and their status should show up. And similarly, if I do kubectl gets svc services, so those services have been created as well. So next thing we could do, I can quickly curl the node port on a worker nodes just to see our app is being exposed as we are expecting. So for that, we just do curl and the worker node IP and the port name, which is we defined it in our manifest file, which is 311. So if I do kubectl get nodes, get no pods wide, it'll tell me oh, I'm typing the kubectl wrong, apologies. Get pods wide. So it'll tell me where those nodes are, the pods are deployed. So they are kind of split between 2 worker nodes, which is good. That's how we want it to. So let's do kubectl get nodes wide to see what the IP of our nodes are. We already know actually, like when we were configuring them. So I know the IP, but I just grab it using kubectl method. So now I know the IP of our one of my worker node, and I'm gonna curl it on a particular port where my service is being exposed actually. So if I do this one, I should get the HTML content, so which will kind of suggest me that my the service is exposed as expected. I could do similarly for the login app, which is being exposed at 312. It's a redirect one, so you may not see a neat response. It's just how that the app works. So we're gonna clear this one now. So we have deployed our app. It's used the service and it's exposed on a node and it's working as we want it to. So the next thing we're gonna do, we're gonna set up the certificate for our blog. So for that, I'm gonna go to my AWS portal and go to ACM service. Certificate manager, and you can create a new certificate. I think it looks like the one that I created has expired, so I have to create new certificate. I'll do that here and provide the domain name that I want to use. So I'll just do this, kulal.com. That's the domain I'm using. And how do you want to do the validation? Set it and just see the status here, and you probably would have to it would pick the domain that you have, and wait, I should be in a different region. Wait a second, my bad here. Actually, that's what I was thinking, because I already have a certificate available. So so that's the one I'm using here. So the certificate I already created before I started the video, and it has been issued and available, and it's synced up and validated using the domain name. My domain is in Amazon as well. So if I go to my Route 53 service. I do have a domain here, so it's the validation didn't take that long for in my case, and it issued the certificate for any sort of a domain ending with .gorlal.com, so anything subdomain would just work fine. So since I have the certificate ready, so the next thing we could do is create the load balancer. For that, so before we do that, when we create the load balancer, the nodes gotta have a provider ID available. If the provider ID is missing, you may not be able to your load balancer may not get provisions as you expect. So there's a command available. We just have to override it with the instance ID. So I'll paste the command here and replace the instance IDs. So this one, the one we don't need to run it on control plane. It only need to be ran on worker nodes, because those would be the nodes that load balancer would set them as target. So next one should be this guy. Okay, so now what I gotta do, I could run this command on my Bastion host, and it'll patch the nodes and have the provider ID available in its specs. So I go back to my terminal on Bastion host. I'll run those commands for both worker nodes, and they've been patched. So the provider ID should be available for my worker nodes now. So the next thing we're gonna do, we're gonna download this Ingress manifest file. So the Ingress is the way we going to create the load balancer. So load balancers only get created when you're creating a service or Ingress resource. So if we review what's in our Ingress here, so at the top, we're telling the kind and the name of our ingress. So we're using a whole bunch of annotations here. So it's the annotations gonna define how we wanna configure our load balancer. If I had defined 443 HTTPS and didn't have a certificate available, I probably would have error out. I probably wouldn't be able to create the load balancer, because when I define the host name, load balancer is gonna auto detect basically that if there's a certificate available for this host, and then it'd be like, okay, yeah, that's the SSL certificate I'm gonna use. So if you don't have a host and you don't define this one like HTTPS, just go with the HTTP, and you won't be able to access it over the web. You still be actually able to. It won't be secure connection. So it's gonna detect automatically and attach that SSL certificate, and then I'm defining certain. Then another annotations are that what the load balancer name and the schema. It's gonna be internet facing or internal, and what's the target type? Is it gonna be instances or the IPs? IPs mean that it would directly forward the traffic to our pods, and then I'm just adding a couple of tags. When it comes to rules, so it's using this host block to gorlal.com, and then I'm defining a couple of paths. So if I'm trying to reach to a home page, blog.com.gorlal.com, it will send me to the blog app service that we created previously. And then if I'm trying to go to login, .com/login, it will send it to login app service. And then similarly for the logout, the ports that we are using, these are the service ports. We're not going to use node ports, we're using service ports. So that's how you create the Ingress resource. So since Ingress is defined, it would communicate with our load balancer controller and create the load balancer for us. So now let's quickly go back to our terminal, and okay, yeah, we did download the Ingress. So if I just run kubectl create f Ingress YAML, it will create the Ingress. If there is some sort of issue, if for whatever reason it can't communicate with the nodes, can't communicate with worker nodes or the nodes, you'll probably see a webhook error. And if you look into the logs of the load balancer controller, you will notice that it might be missing provider ID. So if you defined any sort of a value that it's not applicable, or you'll see the error in load balancer controller. So let's quickly review that. So if I go to if I just describe Ingress, I'll know that if there are some issues with my Ingress or not. At this point, it's just saying that is successfully reconciled. Oh, it has provided even the address for me, that the DNS name. So what I can do, I can just grab this. So that means everything kind of went just smoothly. So I could even look into my load balancer controller logs too. So if I just run Kubectl log and the load balancer logs, it'll tell you how it is kind of provisioning the load balancer. It'll tell you that it's creating the target groups and registering the targets. It's also creating the security group. The security group for the load balancer would allow the communication coming in from internet on port 80 and 443 as we defined in annotations. And it also provisioned the security group, either attach a new one or modify the existing security group that is attached to the nodes. And so the communication from the load balancer is flowing just fine. So everything is done by the load balancer controller. So if you view its log, it'll give you all that information on what it is doing. So I'm gonna describe the Ingress real quick. So now I have the address for my load balancer. So I could essentially access it directly from internet, or I could add a CNAME record for my subdomain. So I have blog to Grolol. Previously, before I started the video, I created this load balancer. So I'm going to update the value here to a new load balancer's address and save. Let's quickly try to access it, see if I could access it yet. Oh, it is working. Oh, perfect. So it looks like our load balancer was provisioned just successfully. If I go to my load balancer, it should be in the active state. Oh yeah, so it has listeners at port 80 and 443, and those has 4 rules. And they are forwarding the traffic to 2 different target groups. So the first one is for the login app, and the second one is for the blog app. So one thing I want to point out that you may notice that the login app target group may showing the health status unhealthy. You could modify the health check to wherever this app do the health checks and change it to /health. It will do the health checks just fine. Right now, if I go to I opened up my Firefox so that just in case there's no cache. So this is the app. So now I'm talking to my domain, which is talking to my load balancers, and everything is just working fine. So if I click on login, it's redirecting to the login service just fine as well. So if I just log in here, you could use, I think it's admin, and the password is password. You'll be able to log in successfully. As soon as you log in, it will redirect you back to the home page. And there's the about page. If you click on the YouTube, it'll take you to my YouTube, and if you click on the blog, it'll take you to my website. Yeah, so everything is just working as expected. If I click login back on it, it'll tell you you're already logged in. If you can log out or go back to the home page. If I log out, now it's telling me if you want to log in again or go to the home page again. Just go to the home page. There's nothing fancy. I could essentially have a logout button available at the top right corner. Once I'm logged in, I just wasn't too much focused on the functionality of the app. I just want to have something that I could utilize and expose it using Kubernetes. our app is working as we're expecting. If I just come back to this target group, it's whenever we do the next health check, it should just work. Oh yeah, now it's in a healthy state. So the path needed to be modified for this target group so that the nodes show up healthy. This is all of our nodes that we created, the Bastion host and the worker node and the control plane. So everything is working as expected. And when it comes to cleaning it up, the first thing you probably want to do, delete the Ingress app. And then just destroy the resources using Terraform. So I'll just wait for my Ingress to be deleted. Sometime it could take a little longer, so you might want to be patient with this one. It does have it is going to delete all the target groups, everything that we created, so it could take a minute or two, perhaps longer. Oh, they're gone already. So or it could be super quick. Go to a load balancer, or there's nothing there, so it's already gone, so it's already deleted. You don't have to even log out here. I go to switch the tab, run Terraform destroy, and it's gonna destroy the infrastructure, whatever I had provisioned, so that, you know, if it's just doing it for demonstration. I don't want to get billed for something that I'm not using. So confirm this one. Now it's gonna destroy all of my infrastructure. So yeah, so this is it with this tutorial. If you have any questions and if you run into any issues when you just do it on your own, do let me know. I'd be happy to help you guys out in any form or way, get back to you sooner than later. Yeah, thanks for watching. Again, there are other videos available on how you can set up your self-hosted cluster and using AWS console and Terraform. Do check it out. Yeah, thank you.